Okay, what I just wanted to do here was take a couple minutes and try to explain the difference between the way a vertical shift works and the way a horizontal shift works. Vertical shifts work, everybody always gets them right, but let's just talk about them for a minute. In problem 18, they gave us a population, so I'm writing down the population is some function of t. I actually drew a little picture here because I wanted something to refer to, and most populations actually grow very fast at the beginning and then tail off, so that's what I drew. Now, I'm going to think of this one right here. That's my old p. This is my new p. What's the difference between my new p values and my old p values? Well, we have them right next to each other to compare, which is great. Yes, I can tell that my new p values are exactly 100 units higher than my old p values. And since it's height and these are higher, we just raise that whole second graph up and get the new graph and get p plus 100. Everybody does this right. You're already doing it right, so I don't want to harp on this too much. Let's go over to the horizontal shifts and start talking about the differences. Even with the horizontal shift, I still have original graph, so I try to draw the same original graph we had before. But this time, the t plus 100 is on the inside. And I really don't have t to actually look at to compare here and here. So what's going on? Well, if I look back at my original one, you can see that I didn't do anything to the stuff on the inside that says leave the t-axis alone, then take your function and add 100 to it. So this one says leave the t-axis alone, but lift the graph up 100. The other one's completely different. This one says move the t-axis 100, but leave the graph alone. Now, how am I supposed to do that? Well, you can see here that I left the graph alone, and I'm supposed to take the t-axis and move it to the right 100 units. Well, how do I show that? When I move the t-axis to the right, the p-axis, which is just like a flag, is going to move along with it 100 units to the right. So what I'm going to do is just put in where my new p-axis is, and you can see that the graph right here would just look right. There's my p-axis, there's my t-axis, and my graph would sit like this. Now you can see that this actually looks like I moved the original graph backwards 100 units. That's what it looks like. That's not what I did. What I did was I left the graph alone, I picked up the t-axis, and I walked it 100 to the right. It actually feels correct that way, and it makes it work, but it also explains why there's such a difference. With horizontal shifts, you're doing stuff to the axis and leaving the graph alone. With vertical shifts, you're leaving the axis alone and doing stuff to the graph.